Assalamualaikum. Welcome to ILAM Research Webinar Series 2024. ILAM Research Webinar Series is a platform for ILAM to share the findings of the research conducted by ILAM under the Education and Research Committee. My name is Dr. Jasasikin. Today, we will be sharing another research findings conducted by one of the researchers on behalf of ILAM. For your information, ILAM have launched 3 areas of research in 2023. Today, we will be sharing the research findings from research conducted by Assistant Professor Dr. Siti Ismail from UTM on estimating carbon sequestration and storage by an urban forest in Malaysia, a case study of Hutan Bandar MBJB Johor Bahru. While the researcher presenting, I would like to invite all viewers to share your views, suggestions, and also engage with the Q&A session with the researcher through the comment box below. With that, I would like to invite Dr. Hannah to share her research finding from her study. Okay, Dr. Hannah, the floor is yours.
Thank you, Dr. Jasa. Okay, Assalamualaikum and a very good day to everyone. My name is Siti and I'm from the Department of Landscape Architecture, University Technology, Malaysia. And today I will be presenting my research on carbon sequestration and storage by urban forest in Malaysia with a case study of Hutan Bandar MBJB, Johor Bahru. So as we all know, climate change and global warming is impacting lives worldwide, and this is particularly important in urban areas as natural surfaces are being replaced with impervious surfaces such as streets and roadways. And Malaysia is one of the countries in East Asia with high carbon emissions, and the majority of this carbon is mainly related to the energy sectors. And of course, efforts are being made by the governments to reduce these carbon emissions by cutting down on the energy sector. But bear in mind, there are also other opportunities and strategies for other sectors to achieve these reductions, and this can be done by promoting green cities concept. And this includes increasing areas of and preserving greeneries in urban areas. Urban forests help deliver ecosystem services to humans residing in urban areas, and this includes providing spaces for recreational purposes, helping to regulate urban temperatures, helping to reduce the risk of urban floodings, and also reducing noise pollution in urban areas. Urban forests, also known as nature-based solutions, help to mitigate urban environmental problems associated with climate change in cities. Urban forests act as carbon sinks due to high carbon uptake by fast-growing forest plants and also trees that are within the urban forest. The rate of carbon sequestration and also storage differs among different forests and trees, and this is influenced by many factors including local temperature, rainfall, topography, soil conditions, species, and also tree characteristics. And therefore, the main research aim of the study is to investigate the current functions and capacities of urban forest in Johor Bahru to help reduce atmospheric carbon dioxide levels by examining various factors that influence carbon sequestration and storage. And this will be done through 2 research objectives, which are first of all to assess the potential roles of urban forests in reducing atmospheric carbon dioxide in Johor Bahru, Malaysia. And secondly is to determine factors affecting carbon sequestration and carbon stocks of MBJB urban forest in Johor. So this is the study area which is located at the MBJB urban forest in Johor Bahru. As you can see, it is located within the Johor Bahru city centre, located in the Johor state. The site is located 1.5 km from Johor Bahru city centre, which covers an area of 56.52 acres of land that is surrounded by government offices, education centres, and also residential areas. It has a high vegetation density covering almost 60% of the total area, with a stand age of up to 31 years of age. And the site is mainly used for recreational purposes for urban dwellers in Johor Bahru city centre. Within the site boundary, 10 sampling plots were selected of 10 meter by 15 meter, and the locations of each plots were selected based on the ease of access in order to collect the data and also the number of trees that were available within that particular area. Tree heights and also DBH, diameter at breast height of each trees, were measured for each of the trees, and then the tree height measurements were conducted using the single pole method. Each tree species were identified by an expert botanist from University Kebangsaan Malaysia, and then carbon data was obtained using the allometric equation by Chavez for tropical forests. Overall, there were 90 trees with 22 species were identified and measured within the 10 sampling plots in the MBJB urban forest. In terms of tree categories, there were 5 small trees, 8 medium-sized trees, 59 large trees, and also 18 trees with extreme height. Kaya senegalensis and also Vitex pubescens were the tallest recorded species on the site, which was up to 45 meters, followed by Syzygium grande of 40 meters. And Kaya senegalensis had the largest DBH of 86 centimeter, followed by Acacia mangium. It was found that most of the trees falls within the large tree categories with DBH and height ranging between 11.5 centimeters up to 56 centimeters, and also 12.2 meters and up to 30 meters in height. And this indicates that most of the trees in the site were planted between 10 to 30 years ago, which also indicates that the MBJB urban forest can be categorized as relatively a young forest. And although research have found that mature trees are frequently reported to be able to store more carbon due to larger DBH and presumably taller heights, thus having more upper crown canopy and also a denser wood density, but it is also worth noting that younger forests may also tend to sequester carbon at a faster rate due to higher growing rate, and also more trees can be arranged and crowded together due to its smaller size. And this is very crucial in limited spaces of urban areas where we are facing lack of land to plant trees nowadays. In terms of tree diversity, based on the field survey, 22 species were identified within the 10 sampling plots that were covering an area of 1,500 meters square. And this showed a relatively rich diversity of tree species and provides a robust quantitative descriptor of the urban forest structure of the MBJB urban forest. And such diversity is crucial because it contributes to a complex forest structure encompassing a varied mix of species richness and leaf characteristics. When comparing the carbon storage between each species that were observed in the site, it was found that Kaya senegalensis stored the most carbon with 15.34 ton per hectare of carbon, followed by Acacia mangium, which stored 14.04 ton per hectare of carbon. And Cratosylum species stored the least amount of carbon, which was 0.03 ton per hectare. There were positive correlations that were found between carbon stored within the tree and also tree height and DPH. And Kaya senegalensis were found to have stored the most carbon, closely followed by Acacia mangium and also Fragria fragrans. And this was found to be highly associated with the heights of these species that were measured on the site. So for the Kaya senegalensis, the average height was 29 meters, and most of these species were categorized within the large to extremely large height of trees. And Kaya was also among the tallest trees that were observed in this study. And similarly, Acacia mangium had the height range between 22 to 33 meter, and as well as Fragria fragrans that ranged between 19 to 34 meters. And trees with lower height were found to generally contribute to low carbon storage. DBH of the top 3 species that captured and stored the most carbon, which were Kaya senegalensis, Acacia mangium, and also Fragria fragrans, were among the largest, ranging between 14 to 86 centimeter of DBH. And this is consistent with the carbon storage performance as well as the overall tree heights. And it can be also concluded that larger DBH indicate a more mature and robust tree, which may have been able to accumulate more biomass and also more carbon over time. And this relationship involves tree wood density, whereas trees with larger DBH typically have denser wood and thus can store more carbon per unit volume compared to trees with smaller DBH. There are several tree characteristics that were found to have influenced carbon sequestration and also storage, and among them is tree wood density. So trees with higher wood density tend to grow more slowly because of a lower photosynthesis rate, which means that carbon sequestration that takes place more gradually. But these type of trees also tend to store more carbon compared to those with lower wood density but a faster growth rate. So fast growing trees typically have lower wood density but can sequester more carbon over a short period of time. So a mix of tree species is recommended with varying wood densities, which is also expected to give a more positive impact to the ecosystem by enhancing the resilience and biodiversity of the forest. And secondly is the growing conditions and growth characteristics. So optimal growth conditions such as adequate lighting, water and also nutrient availability within the soil system can enhance a tree's growth rate and also biomass accumulation, leading to a greater carbon sequestration and storage. So soils that are rich in essential nutrients with well-drained and aerated soils can support vigorous tree growth, leading to a greater biomass accumulation and also carbon storage. So while older trees typically store more carbon, healthier trees tend to sequester more carbon more efficiently. So in terms of tree size, taller and older trees tend to be denser and store more carbon compared to smaller trees. And larger and taller trees have consistent access to the sun because taller trees canopy can reach the top of the forest and use this solar energy and also tend to have greater number of leaves to absorb carbon dioxide. And in terms of canopy structures influences carbon sequestration and storage by affecting the amount of sunlight that penetrates through the lower leaves and onto the forest floor. And a complex canopy structure supports greater biodiversity, which improves the ecosystem stability and also resilience and further aiding carbon storage of the urban forest. A dense and well-developed canopy with multiple layers enhances light capture and also increase photosynthetic activity, which leads to higher carbon uptake. And finally, canopy gaps and variations in the canopy height can also promote growth in understored vegetation, contributing to additional carbon sequestration. In order to optimize the amount of carbon stored within an urban forest ecosystem, there are several recommendations in terms of tree planting schemes that we would like to suggest based on this research. The first one is to diversify species, as species diversity improves the resilience and carbon sequestration capabilities of urban forest. And diverse species can also occupy different ecological niches and contribute to a more stable and productive ecosystem. Secondly is the structural complexity, which includes adding more vertical and horizontal complexity that can enhance its carbon sequestration potential. And this includes having multiple layers of vegetation, for example, ground covers, shrubs, understories, and more different height of tree canopies with varied spatial arrangements of trees. And thirdly is a dense planting in appropriate areas. So for areas that are not designed for necessary recreational spaces, for example, an open space for a picnic and so on, needs to be planted more densely to balance the recreational use with ecological function. And finally is management and maintenance, is to have regular monitoring regime, pruning and replacement of trees that can ensure the forest remains healthy and continue to grow optimally. So in conclusion, based on this study, we found that tree attributes such as species, height, canopy structure, trunk size, and also growing conditions plays an important role in sequestering and also storing carbon in their above ground biomass. And this study highlights three key species, which was Kaya senegalensis, Acacia mangium, and also Cryptophyllum fragrans, effective species and shows a promising attribute for urban forest planting aimed at enhancing carbon sequestration and storage. And urban forests are seen as a vital tool in the fight against rising atmospheric carbon dioxide levels by carefully selecting and planning the different species and planting diverse tree species, and also creating multi-layered forest structures to maximize the carbon sequestration potentials of urban green spaces. And beyond carbon sequestration, a well-planned urban forest also offers numerous other ecosystem services that improves the quality of lives of urban residents. For example, purifying air and water, regulating temperature, act as noise reduction, and also providing habitats for wildlife in urban areas. And finally, a diverse and well-structured urban forest serve as a critical component for urban infrastructures in contributing both to the environment and also to human well-being. I would like to take this opportunity to thank all the collaborators that contributed to the successful completion of this research, and also, of course, to thank the Institute of Landscape Architects Malaysia, ILAM, and also the Ministry of Higher Education for providing financial support for this for the completion of this research.
Thank you very much, Dr. Hannah. To our viewers, feel free to engage in the discussion with the researcher through the comment box below. And don't forget to screenshot your attendance in this webinar. Among other findings, the research revealed that the three characteristics such as diameter at breast height and canopy size significantly influence the ability to sequester and store carbon. Several plant species were selected for the study to demonstrate the carbon sequestration and storage capabilities. The characteristic of these species can serve as a reference for assessing the carbon sequestration and storage potential of the other species with similar characteristics. For more detailed information, please visit our website where research report will be published. We hope this report will serve as a valuable reference for everyone, helping to advance our profession and contribute to the well-being of the people. On behalf of ILAM, I would like to once again thank Dr. Hannah for conducting this research and sharing it with us today. Thank you everyone for joining ILAM Research Webinar Series 2024. And don't forget to like and share this ILAM webinar, and also like our ILAM FB page and subscribe to our YouTube channel. Assalamualaikum. Have a good day ahead.